Let us solve for all the values of y in this expression, y to the power of 12 minus 1 equal to 0. We're going to find both the real and the imaginary solutions of the value of y. But before we start, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more content on mathematics. Now, in order to simplify this expression, I want you to note that 12 can be equal to 6 multiplied by 2, right? So if 12 is equal to 6 multiplied by 2, that means I can simplify that expression to give me y to the power of 6 multiplied by 2 minus 1, and this will be equal to 0. Now from this expression, you can see that I can make the both a perfect square because 1 square is still equal to 1. So that expression can simply give me y to the power of 6 all squared minus 1 square, and this will be equal to 0. Great. Now having seen this, you know we now have a perfect the difference of 2 squared. So recall that if we have a minus b all squared, that this can be equal to a plus b multiplied by a minus b. So having seen this, we can see that the value of our a here is equal to y to the power of 6, and the value of our b is equal to 1. So if we simplify this, so this will give us y to the power of 6 minus or plus 1, right? And then we'll have multiplied by y to the power of 6 minus 1, and this will be equal to 0. Great. Now, having done this, we are going to simplify this further. And from this expression, you'll come to see that we can isolate this y to the power of 6. And if we isolate that, you'll find out that y to the power of 6 minus 1 will be equal to 0 because this other one will be equal to 0. So we can expatiate this to now give us, this is going to give us y to the power of 3 multiplied by all squared 2, right? Minus 1 square, and this will be equal to 0. So with that, we can still arrive to what we call a d of 2 square. So if we clear up that, we are going to have y to the power of 6 plus 1 multiplying y to the power of 3 plus 1, right, multiplying y to the power of 3 minus 1, and this will be equal to 0. So we've only expanded y to the power of 6 minus 1. So we are going to also still consider one simpler expression too. From this expression, you can see that having all these products, y to the power of 6 plus 1 can be equal to 0. From here, we can see that in the first case, y to the power of 6 plus 1 can be equal to 0. We can also have y to the power of 3 plus 1 to be equal to 0. And we can also have y to the power of 3 minus 1 to be equal to 0. So we can simplify this separate part of that equation in order to find the various values, both real and imaginary, of y to y. Now, if we do that, let's start with y to the power of 3 minus 1. So if we have y to the power of 3 minus 1 equal to 0. If we simplify this, remember, this expression can also be like a quadratic expression where we have a to the power of 3 minus b to the power of 3. This can be equal to a minus b multiplied by the first square plus the first multiplied by the second plus b what square. So from this expression we can see that 1 can be up to the power of 3 because 1 to the power of 3 is 1. So that expression can simply give us y to the power of 3 minus 1 to the power of 3 equal to y minus 1, right, all multiplied by y square plus y plus 1 what square, right? And all this will be equal to 0. So if we simplify this, we'll come to see that y minus 1 is equal to 0. Likewise, we can also have y square plus y plus 1 to be equal to 0. So we can simplify this to get the few values of y. The first few value of y will be equal to 1, and that is y1. So we see that our y1 is equal to 1. So from this expression, using the quadratic formula, y equal to minus b plus or minus square root of b square minus 4ac divided by 2a, we can be able to find the value of y. So here we can see that a is equal to 1, b is equal to 1, and c is equal to 1. So if we simplify those terms into that expression, you come to see that the value of y will be equal to negative 1 plus or minus square root of 1 square minus 4 multiplied by 1 multiplied by 1 divided by 2 multiplied by 1. So if we simplify that, we're going to have y to be equal to negative 1 plus or minus square root of 1 minus 4 divided by 2, right? And so we'll have the value of our y to be equal to negative 1 plus or minus square root of negative 3, and that will be divided by 2. So simplifying that further, our y will now be equal to negative 1 plus or minus square root of 3 imaginary divided by 2. So the value of y in this aspect, we are going to consider it to be y2. The value of our y2, which is positive or negative, our y2 will be equal to negative 1 plus or minus the square root of 3 imaginary divided by 2. And that is the second solution, which is an imaginary solution to that expression. Now the next one we want to consider is the next value, y to the power of 3 plus 1 equal to 3. So if we have y to the power of 3 plus 1 equal to 0, and that expression will now give us, to further find the values of y, we have y to the power of 3 plus 1 equal to 0. Now if we note that this can give us y to the power of 3 plus 1 to the power of 3, and this will be equal to 0. Now simplifying this algebraic term, considering the positive sign, that this expression will now give us y plus 1, right? Exactly what we do on the other part, and this will be y square minus y plus 1, and this will be equal to 0. So from the first expression, y plus 1 equal to 0, we see that our y is equal to negative 1, and that will be our y what? That is going to be our y3. So our y3 is going to be negative 1, which is a real number. Now we're going to consider our y4. To get our y4, we're going to solve y to the power of 2 minus y plus 1 to be equal to 0. Using the quadratic formula, we'll have negative 1, right? Or we have negative b plus or minus square root of b squared minus 4ac all divided by 2a. Now from that expression, you see that your our a is equal to 1, our b is equal to negative 1, and our c is equal to 1. So if we simplify that, we'll have the value of our y to be equal to negative 1 negative multiplied by negative 1 plus or minus square root of minus 1 all squared minus 4 multiplied by 1 multiplied by 1, right? And all divided by 2 multiplied by 1. So what do we have? We have our y to be equal to negative multiplied by negative 1 plus or minus square root of 1 minus 4 all divided by 2. So what do we have here? We'll have this to give us our y to be equal to 1 plus or minus square root of negative 3 divided by 2. So that is the solution to the fourth value of y. If we simplify that, we'll have our y to be equal to 1 plus or minus. Remember, this is going to give us square root of 3 multiplied by square root of negative 1, which is what? Which is going to give us imaginary, considering the complex number. So our y will be equal to 1 plus or minus square root of 3 imaginary divided by 2. And this is the solution to y4. Good. Now we're going to consider the final solution, and the final solution is going to be y to the power of 6 plus y plus 1 equal to 0. Y to the power of 6 plus 1 equal to 0. So how do we solve that? Let's go back there and then see how we can solve that. The final solution, which will give us y5 and y6, is going to be y to the power of 6 plus 1 equal to 0. So we can see now that this can be equal to y to the power of 2 multiplied by 3 plus 1 to the power of 3 equal to 0. Why? Because 2 times 3 will give us what? 6. So that expression, considering an algebraic formula, that expression will now give us y2, right, plus 1 multiplied by y, that is b squared, that is y to the power of 4 minus y squared. I know you get this, and this will be plus 1, and all this will be equal to 0. So if we simplify this, we're going to see that our y squared plus 1 will be our first case, and that will be equal to 0. On the other hand, we'll have our y to the power of 4 minus y squared plus 1 equal to 0. So from here, you see that y squared is equal to negative 1. So if we find the value of y by taking the square root of both sides, we'll have this to be equal to plus or minus the square root of negative 1. While this clears this, y will be equal to plus or minus imaginary, because the square root of negative 1 is imaginary, and this is our y was 5. So from here, we can get the other value of y6. We want to find y6 here, that means this will give us y squared multiplied by 2, right? And with this, we'll have what we call a very good quadratic equation in y squared, right? So we can simplify using the quadratic formula. And if we use the quadratic formula, you can see now that the value of our a will be equal to 1, value of our b will be equal to -1, and the value of our c will be equal to 1. And what are we looking for? We are looking for y squared to be equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. So let's simplify this. If we simplify this by inserting those parameters, we'll find out that our y squared will now be equal to negative multiplied by -1 plus or minus square root of -1 square minus 4 multiplied by 1 multiplied by 1, right? C is equal to 1, and all these will be divided by 2 multiplied by 1. So if we simplify that, we'll have our y squared to be equal to 1 plus or minus square root of 1 minus 4 divided by 2. And what will this give us? This will give us y squared equal to 1 plus or minus square root of -3 divided by 2. So if we simplify this, you're going to see that the value of our y can now be equal to that parameter is going to give us the total square root. We'll have the total square root of 1 plus or minus square root of 3 imaginary divided by 2, and this will be y what? 6. So this is another solution to the value of what? Y. So if you see, we have one solution, we have the second solution, which is this. We also have the third solution, which is this. We have the fourth solution, which is this. We have the fifth solution, which is this. And we have the sixth solution, which is finally 1. So we see all these are the values of y that satisfies that expression given to us up there. I know you did enjoy watching this math solution, though a lengthy one. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching.